React's reconciler runs 60 times per second. Your frame rate doesn't. That's the first thing developers building 3D games in the browser discover when React 3 Fiber, a thin React wrapper for Three.js, quietly tanks performance the moment state updates touch the render loop. The problem is architectural. React is render-oriented, designed for top-to-bottom state flow. 3D games are data-oriented, demanding real-time mutation of position, rotation, and shader uniforms every single frame. Call setState inside useFrame and you've just routed 60 updates per second through React's scheduler, triggering component re-renders that recreate expensive geometries and materials from scratch. Frame rates collapse from 60 frames per second to 20 frames per second in seconds. But that's not the only enemy. WebGL won't garbage collect your GPU resources. JavaScript won't either. Textures loaded as ImageBitmap objects never die unless you explicitly call texture.source.data.close before texture.dispose. Miss it once and memory climbs until the tab crashes. Coordinate systems fought back too. Euler angles and quaternions don't mix mid-frame without gimbal lock or floating point drift. One developer spent 2 weeks fighting unstable rotations before discovering the rule: never convert between representations inside update. The June Solstice Game Jam on DEV community attracted dozens of submissions. Most learned the same lesson: the browser gives you the tools. It just doesn't tell you which ones will fight each other. Sandy Metz, a software design expert, published a blog post in 2016 arguing that duplicating code is often preferable to creating the wrong abstraction. The post challenges conventional programming wisdom that prioritizes the dry, don't repeat yourself principle above all else. Metz demonstrates how premature or incorrect abstractions create technical debt that becomes harder to undo than simple duplication. This perspective directly impacts how development teams approach code architecture and refactoring decisions in production systems. The broader implication reflects an industry-wide shift toward pragmatism over dogma in software engineering, recognizing that rigid adherence to principles can sometimes cause more harm than good.